Hello, everyone. I mean, I love the size of the room here. I mean, you could land an aircraft. But good afternoon. My name is Ismael. I'm the co-founder of Lagrange. And so today I want to start with a little bit of a story. So a few years ago, when I founded Lagrange, I was in San Francisco, and I was at a happy hour before we had raised any money or had any team, and I was talking to a man about kind of where he saw the space going. And what he said to me was that every app was going to be a cross-chain app. And at the time, this was like a little silly. It was this idea that like Cardano was going to compose with Polkadot. It just doesn't really feel real. This was before the roll-up vision of Ethereum materialized in any way. And I took him at his word, and now we're several years later, and I can't think of a single DeFi app that doesn't have a wrapped asset. I can think of very few DeFi apps that don't have multi-chain deployments or don't integrate with bridges or messaging protocols. And so that prediction was very prescient because it came true. And so this week I've been making an equally bold prediction, at least to some people, and that is that over the next 2 years, every app will be a ZK app. It will sit on a chain that has an execution space that is proven. It will use exogenous data from ZK TLS or ZK Oracle constructions in some way. It'll extend its execution using coprocessors, but someplace in every application's design, it will use ZK. At Lagrange, we're building the substrate for that proof-based future. If we think about the last iteration of blockchain applications, they used proof-of-stake guarantees for almost everything. Bridges, POS. Oracles, POS. Execution spaces, POS. But with the fundamental innovation we're seeing in proving system design, proving back-end design, things like smaller field sizes, faster recursion, as well as hardware acceleration, we're starting to see the hegemony of POS erode. What we're seeing is the materialization of a proof-based future. And where we see this going is the ability to prove everything. One layer, a network of networks, generating proofs for every application in crypto. Prove anything, anywhere. And so Lagrange, at a very broad level, and we'll get into very shortly what Lagrange actually does, is an economy of proving. It is universal, infinitely scalable, and delivers proofs in production today to some of the top DeFi and NFT projects. We do this on top of a layer that generates these proofs that can service our proprietary applications, like our ZK coprocessor and our state proofs, as well as third-party partners and friends who deploy on top of us. So prove anything with Lagrange. You can think about our ecosystem and our networks as an interconnected web of applications, users, and provers. Our ZK coprocessor, which proves SQL-based computation, is in production today and is servicing proofs to some of the top applications in DeFi. Think EtherFi, Gearbox, and many more to be announced very soon, as well as top applications in consumer. Think Azuki, Sappy Seals, close partners of ours who use use ZK to enable new application functions, as well as roll-up teams, interoperability teams, folks like Polymer, Axler, Layer Zero, who use our proofs to enhance the security posture of their cross-chain applications. And generating these proofs is not a pipe dream. It's not people in their basement who are discovering ZK for the first time. These are institutional operators running provers for us. We have Coinbase running our provers. We have OKX running our provers. We have P2P running our provers. The same people who you would want to do decentralized proving for you in any application are already doing it on top of our network. And so what makes what we do unique? I'm sure there's been like 5 conversations today about decentralized proving. It's an area that people have been enjoying talking about. But what we believe is the future isn't a monolithic architecture for proving where you try to funnel all the proving demand onto one network where one greedy team stakes their token into it to make it shoot to the moon. What it is a bunch of independent markets that operate in the domain of a certain type of proof they need to generate that are customizable. You are both universal and specialized. You are both ubiquitous and customizable. And that's what Lagrange's decentralized prover networks and prover markets do. We have a very simple abstraction of 3 components: a gateway that does auctions, provers that generate proofs within these auctions, and work orchestration to maximize utilization of latent resources. So how does it work within a given gateway or sub-network within the broader Lagrange ecosystem? Well, you generate a request for a proof. You send that proof to a gateway. The gateway conducts an auction over who is going to be generating that proof. Provers bid on the ability to generate that proof, and they're verified against the hardware requirements, stake requirements, and permissioning requirements over who's allowed to generate proofs in a given domain. So for example, if you have a time constraint and you generate that proof on time, you can receive a reward for doing so. If you don't, you will receive an economic penalty in the form of slashing or non-payment. And all of this stuff is configurable. The type of penalty, this type of staking, the permissioning requirements, the type of hardware, each section or sub-networks within the overall design have agency to architect all of these features how they see fit. They don't have to go back to first principles and try to rebuild a million networks from scratch. They can use a well-defined existing stack. And as I was saying, a single gateway with shared bandwidth is really kind of the way we see most of these prover networks today working. You want to use an existing prover network, you contact their team, and they go, oh yeah, deploy on us, and you'll be getting your proofs generated by someone who's staking my token, and I'll get all the cash flow from that and all the margin on it. It really isn't compelling if you have demand for proving, right? Why would you put your proving order flow on someone else's network when they stake, they get the money from it, and you have all the order flow? It doesn't really kind of match with what we see in crypto. You don't give something for free in business. But performance also degrades too in these architectures because you're trying to fit the proving demand for potentially thousands of rollups through this kind of single monolithic network. It doesn't scale. And so we've envisioned and designed an architecture that's fundamentally dissimilar from this. It is fundamentally able to scale horizontally across a wide domain of proof generation demands, from rollup ecosystems to L2s to NFT and DeFi protocols working with our co-processors to a bunch of other things that we're excited to announce more of soon. And the key principle is that this is not a network as much as it is a network of networks, each independent, each running a similar stack that has the same APIs and the same gateways, but independent in the economic conditions that it sets forth, and independent in the proof types that it wants to support, which lets us scale to an incredibly heterogeneous amount of complex proving demands. The network doesn't degrade performance through the more circuits it supports within its provers, because the network is able to specialize provers. If a prover wants to generate a proof on Plonky 3, Plonky 2, Miden VM, Boojum, Starknet prover, really anything, the network can, by having a special domain within that network where provers are optimized to generate proofs for that type. And this gives a significant amount of flexibility while also allowing the overall network of networks to be universal to any type of proving demand. And so fundamentally what underpins this is some research from our team that we've published very recently. We submitted to Financial Cryptography. I recommend anyone here who finds mechanism design interesting to go look at this work. But what it is a double auction mechanism for resource allocation that we call DARA colloquially. And put simply, it's the first work in an academic context that explores how to create an incentive-compatible auction design for two-sided resource marketplaces like decentralized proving. And so the goal of this is to be able to formally prove a series of properties, things like collusion resistance, computational efficiency, budget balancing, welfare maximization, that within the context of a proving fee mechanism or transaction fee mechanism need to be reached to guarantee incentive compatibility. And the work is able to reach all of these properties. And to put very simply why you actually would want incentive compatibility in any type of decentralized proving architecture, let me just give a very simple example. Assume you have a market that has two participants. A batch comes in to generate a proof, and one of them, they both bid, and they switch off, in essence, who wins. So each one generates 50% of the proofs in this market, right? A toy example. Well, what does each one have to bid to be profitable? 2 times the cost to generate that proof, because their utilization rate is 50%. This is really not cost-effective or computationally effective, right? What you need to be able to do is to have mechanisms that both are able to guarantee fair pricing and are able to guarantee resource maximization across the network, or utility maximization across the network. And this is the type of stuff that is considered in these designs and is applied within our network singularly. You know, this is really not an architecture that you would use that you would develop if you just needed to justify a token usage. What this is an architecture you develop when your end goal is to ensure that you're able to do the types of proving you want to do at the lowest cost possible with the highest liveness guarantees possible. Institutional provers and effective incentive design. So it's production ready. We've been in production for the last 5 months. We've generated several million requests for our coprocessor that we've delivered to a lot of the top DeFi and NFT apps on-chain. And we've very recently opened up the network for other types of applications to deploy on top of as well. You know, we kind of dog-fooded the first version of this with our coprocessor, but we think the applications of this are a lot more kind of broad-reaching. But to touch on what we build on our network, it's a ZK coprocessor. So we have the first SQL-based ZK coprocessor in a space right now that allows us to verify SQL computation over blockchain data. Think of it like Dune Analytics, but verifiable. And what this lets us do is to take applications that sit on chain today and to have them stay where they are and extend their execution to do new things that were otherwise impossible. Consider lending apps that want to determine funding rates over a period of time. Consider DEXs that want to be able to expose average prices so that you can have better liquidation engines. All of this stuff can't be done in Solidity, but can be proven off-chain and verified back on-chain asynchronously with ZK. And so the way it works is you register a contract with our ZK coprocessor. You can then submit a query to the coprocessor, which generates a proof of a computation over the underlying data. And then the proof is submitted back on-chain and is verified by the smart contract that requested it. It's a very, very similar design pattern to if you wanted your Web 2 app to make an API call to some other server, but instead, you're able to make a call from your contract on-chain to an off-chain engine that generates proofs within our network. And so I said a few times today that this is in production. And I started by saying that I think every application in DeFi, NFTs, consumer, anything on-chain, as well as all chains, will become ZK. So I want to stop for a minute and walk through a couple examples of where this is used in production today. One of our partners is a company called EtherFi. They are a liquid restaking protocol on top of Ethereum. And they have about 5.5 billion in TVL, and this number might actually be higher now because ETH has just skyrocketed the last few days. But what they want to build is the first crypto-native on-chain credit card. And what they want to have is a bunch of features that are Web 2 native, but they want to do that in Web 3. They want to have a cashback, for instance. So you spend, and then you get 3% cash back that you can claim. Intuitive, simple, and if I offered you a credit card that didn't have cash back, you probably wouldn't use it. But it's kind of hard to do that on chain. How do I determine how much a user spent over an arbitrary window of time? How do I record that in a smart contract? Do I want to spend the amount of money for the accumulators on chain to do this? Not really. What you can do with a coprocessor is very simply structure that computation in ZK, off-chain, and then verify it back on-chain. In essence, select all transactions owned by a user X over some interval, sum them up, and multiply them by 0.03. Very simple to write in most languages, very simple to write in SQL, very impactful to a production customer. Another of these is a little bit more fun. And this is some work that we've done with a company called Azuki. They're one of the top NFT collections in the space right now, and they sit at a very interesting intersection of anime, entertainment, and Web3. And with them, they want to offer these new fun features to their users. If you own an NFT and you've done certain things on chain, you are eligible to receive a badge. You can be part of a collector's program based on what you've done. But structuring that logic for the issuance, the determination of your actions, the decisioning, is not easy to do in a language like Solidity that only lets you access the present state of the chain with very high constraints on storage read cost. But with a coprocessor, with ZK, and with Verifiable SQL, it's very easy. And finally, Gearbox. They're a top lending protocol in the space. They've been around for a very long time, and they've been very security conscious, and they've been very forward-looking in their features. What they want to build, and what they've been building with us, is a new type of liquidity mining contract, right? If you're a DeFi OG here, you're familiar with the Sushi Master Chef standards. You're familiar with the 1-inch farming pool contracts. But a new version is currently being developed by Gearbox using ZK coprocessor as a primitive. So if you take one thing from this talk today, what I want this to be is this idea that the future is verifiable, that what we are building is an internet, a network of networks that will power this new generation of applications that use ZK for all core functions. So if you want to build this alongside us, or if you're building something that could use this, please reach out to me directly. Please reach out to our team, and I'd love to talk more. Thank you so much for having me.
Thank you, Ismael. Exciting use cases.
Thank you. Any questions?
Nice. Okay.
Oh, we got one. Thank you for not rugging my Q&A session.
Hey, Ismael.
How are you?
Good. Yeah, my question for you is, you had mentioned that the ZK coprocessor is kind of the first network built on top of what you consider like Lagrange's fundamental kind of like infrastructure.
Yeah.
I'm curious, what's like the next thing that you're most excited about, or the two next things that you're most excited about that you think could leverage Lagrange, like their fundamental infrastructure?
Yeah, I can't share the next two because those can't come out. So I'll give you the third.
Okay.
There is a lot of very interesting work done in the cross-chain space over using validity proofs by using consensus proofs or like-client proofs to increase the security posture of cross-chain protocols. Directionally, every single cross-chain protocol wants to use ZK. It's just a question of price, because users of cross-chain tend to be very price sensitive, because you can develop architectures for cross-chain that don't necessarily put much risk on an end user by just having the liquidity risk underwritten by the bridge. But directionally, all these teams want to use ZK. And so there's a lot of work being done by us and then some of our friends over how you can structure zero-knowledge proofs in a way that's capital efficient and cost efficient to cross-chain protocols to use. And I think that's going to be a fantastically large market, especially as the cross-chain space continues to grow. And it's also one that I think people tend to sleep on because it's volume-based. And right now, it's very hard to predict the amount of fees that can accrue from proving based on cross-chain volume.
Great, thanks. Can I ask one follow-up?
Keep going.
Do you envision other teams, other projects being able to come and kind of build their own like ZK networks, like build my own ZK coprocessor on top of Lagrange, rather than the Lagrange team building their ZK coprocessor on top of Lagrange Foundation.
Yeah.
That question makes sense?
Yes, it is. It's a great question. So we actually do have teams doing that right now. We haven't announced what those teams are yet, but when we do, they're quite large groups, and I think it'll be hopefully head-turning.
Cool, thanks.
Of course.
Oh, you got two more.
I love it.
Hey, so you said that Lagrange has been live for 5 months. So who is currently doing the proving right now?
Yeah. How do I go backwards? Okay. Well, we have 85 groups doing the proving. Some of the top line groups would be like Coinbase, OKX, Kraken, P2P, Figment, Impstones. I'm trying to think who else you might know. Luga nodes. They're very good. Alt layers actually improving for us. But 85 we have in production.
Okay, so for example, can I spin up my own?
Yeah.
Okay.
You can do it. If you want to connect me after, I'll give you. You can connect us on Telegram. And my DevOps team can help you.
I mean, that's just a question.
Yeah,
I mean,
it should be pretty easy. It's like
Okay.
30 minutes to run a prover.
Cool.
Does
Awesome.
he need to run AVS operator?
He may, depending on what he wants to prove
I guess
for.
what I mean is, do we need your permission to spin up a node, or like can anyone do it?
Right now, we have a permissioning thing there just to stop
Okay.
like institutional grade Sybil. Partly because like airdrop farmers come in and Sybil everything that they think might be a token drop criteria, and it just is a headache. But we've never turned anyone down. We have a form.
Okay.
You just put your thing in the form and you get whitelisted.
Cool. Thanks.
It's like automatic.
Thanks for the talk. So you mentioned you had a lot of, I guess, partners on the supply side, you call it like that, who offer proving. What do the economics for provers look like? And a follow-up to that would be, if I'm a really good prover, like I have fine-tuned my stack to the max, what's the pitch to get me onto Lagrange?
I mean, we have demand for proofs.
That's it. It's
Very simple, right? If you fine-tune your stack, you want to prove somewhere that has demand such that you can generate revenue and profit, right? It's like if you don't want to have your fine-tuned setup running empty. You have a utilization target you're going to have to hit on that for it to be profitable. It might be a very low utilization target if you're very efficient, but you'll still have that. And so you're going to want that prover to run in whatever domain can actually reach the maximum level of utilization over the interval of time you have that machine for. And that's what we can guarantee that you have with us.
Thank you.
Of course.
Thank you, Ismael.